Okay, welcome back. And today what I'd like to do is I'd like to talk about this idea of minerals and what would actually make a mineral a mineral. And last week we were talking about some items that you looked around in your house and you were looking for different items that may have minerals. And our goal would have been to try to figure out those items and bring them back to school and we'd look at them and see if they are in fact minerals. Well, one thing that you can do is you can put it through a series of tests and look and see if it's actually naturally occurring, if it's organic, if it's a solid, it has to be a crystal structure, and it needs to be a definite or have a definite chemical composition in order for it to be a mineral. So what we're going to do today is I'd like you to work along with me. We're going to make a foldable. So everybody right now has a sheet that looks like this. Take this sheet and fold it like I'm doing right now. Just fold it over. Okay, and then crease it. Make sure it's even. Okay. Next, you're going to need to turn it sideways like this. And you are going to just make little cuts about halfway to the crease so that we have these little tabs. Okay, so we should have a tab for inorganic, naturally occurring, inorganic, solid. I'm going to make a tab here. Crystal structure, make a little tab here. And definite chemical composition. Okay, and this is going to help us with our notes. See, when you flip it open, you're going to write your notes here. That way we can use this for a review and you know that this information is going to be on Thursday's quiz. Okay, so when you're finished, keep these ones shut and then open up naturally occurring. Okay. And grab your pencil and you can go ahead and take notes right along with me. Okay, naturally occurring. Naturally occurring, that means that it's formed by processes in the natural world. So everybody write that down. In order for it to be a mineral, it must be formed by processes. Now, a process is a way to make things work. Processes. Formed by processes in the natural world. So things like synthetic objects or things that are built in like a laboratory, things that are man-made are not examples of minerals because they're man-made. Plastic objects, that's an object that is not formed naturally. People have to actually make the plastic. So plastic is not an example of mineral. So things that are naturally occurring must occur in the natural world. Must be formed in the natural world. Okay, next open up the inorganic tab. And you remember the word organic, that means came from living things. So the word inorganic, that's the opposite. So the opposite would mean that, well, it never formed from materials that were once living. And that's what we'd write down now. So things that are inorganic are never formed from materials that were once living. So things like seashells, that would come from a living thing, and that would not be a mineral. Things that are found like maybe bone fragments, that came from a living thing. So it's not a mineral. It's inorganic. actually, bone would be classified as organic. So in order for it to be a mineral, it must be inorganic. So another idea would be maybe hair follicles, like dog fur. That's not classified as mineral. What about like bark or maybe wood from a tree? Raise your hand if you think that that would be something inorganic. Raise your hand if you think that would be organic. If your hand was up for organic, you are right. That came from a living thing, like tree bark or leaves, debris that falls from a tree, or even grass. That stuff is all organic. So that would not be something that is a mineral. So again, go back to the tab, open it up. Remember, inorganic, that's stuff that's never formed from materials that were once living. Okay, I'm going to close these and then open up solid. Now, solid you should already know because that would have been a vocabulary from the past. And if you remember, we said that a solid means that it must have a definite volume. So write that down. Definite volume. And remember, volume, it means that, an object that takes up space and shape. So write that down. Definite volume and shape. So some people get a little confused with minerals because they might think a liquid is a mineral. Well, that's not true. Now, liquids can have minerals in it. Could have solid things in it. That's where the confusing part is. Now, like lotion, for example, it's a liquid. So that the lotion itself is not a mineral. However, you might have little solids that are in the liquid that possibly could be minerals. And people can actually eat minerals. You have iron in your blood, for example. Now, the blood itself is a liquid, but you know that the liquid has solids in it, like iron. But they're so microscopic, they're small. You need a microscope to see the solid little particles. They crystallize in there. Okay? Kind of an interesting thought. But do not get confused because in order for it to be a mineral, it must be solid. All right? Going down to the next tab and open up where it says crystal structure. Open that tab. And a key concept or a thought from this that you need to know is that it must have patterns. And we're going to look at different patterns from different crystals, actually. They must have patterns that repeat. It's kind of an important thing in order for it to be a mineral. Last Friday, we had a lab called Reaching Saturation, and we filled up a container with water, and we put salt in the water until we reached saturation. And we know that it's at saturation when the water fills up those little spaces in the water, break down and dissolve the solid material, in this case salt. And then we keep adding salt until we reach saturation where there's no more pockets for the salt to absorb or go into those little pockets. And what happens with that? Well, the salt will settle to the bottom, and what happens then? Right, it evaporated. So we're going to take a closer look at that next week. We'll look at it under a microscope to see if we can find patterns that repeat. Finally, there's one final thought that you can jot down right now, and that's the definite chemical composition. Well, in order for it to be a mineral, it must contain certain elements in definite proportion. This ties neatly with last unit when we were talking about the periodic table and atoms and stuff like that. Because the definite proportion, I know that's a math word that means kind of like, well, let me put it this way. H2O. You have 2 hydrogen atoms and an oxygen atom. Proportion. So you have the same proportion or same amount every time. Just like in a compound. So that's why we're going to put compound in parentheses. Okay, and this gives you a general idea. In order for it to be a mineral, it must have these things here: naturally occurring, inorganic solid, crystalline structure with definite chemical composition. These things you need to know by Thursday. So thank you for being such a good listener. You guys